This is a variation of the old proverb that was about, if a man is given a fish, he'll eat for a day, but teach him how to fish and he'll eat for a lifetime. And this is very much the case with phishing as it relates to social engineering as well. Those who are adept at executing this particular style of social engineering attack have almost unlimited potential to exercise this particular type of scam. Now, before we go on and start looking at specific phishing attacks, let's just do a quick definition. You're probably already familiar with the term, but this will hopefully get us all on the same page. And really what we're looking at here is an attempt to acquire sensitive information. So very typically we'll see the social engineer using a phishing attack to obtain things like credentials, a username and password to a site, or other very sensitive personal information, answers to security questions. And inevitably, the objective here of the social engineer is that they have malicious intent. They then want to turn around and monetize this information in some fashion. Now, their ability to be successful is often determined by how well they can masquerade as a trustworthy entity. And this is what you're going to see as we progress. So how can the social engineer, mounting a phishing attack, convince the victim that they are indeed on, say, the bank's website and not a phishing website? Or that the victim is entering details into a Facebook social login and not into a malicious page stood up by the attacker? All of this comes down to how good a job the social engineer can do of their phishing attack. Now, before we move on and start looking at actual attacks, I want to give you a few stats on just how effective this particular mechanism of social engineering really is. This is from Verizon's 2015 Data Breach Investigations report, and it's a staggering figure. So nearly a quarter of all recipients of a phishing attack open the message, and then 11% are clicking on attachments. Now, you'll see many different figures about phishing attacks from many different organizations, but the one constant you'll find is that they always show a very high level of success for the phisher. Now, this is not one of these attacks that relies on a 100% success rate to be effective. You only need one person within an organization that's being phished to open that attachment and allow something malicious to execute within their environment for the attack to be successful. So in this case, 11%, when you're possibly sending out thousands or even hundreds of thousands or millions of emails, could actually be a really high success rate. Now, it's because of this that we see phishing featuring so frequently in online attacks. More than 2/3 of the incidents that Verizon looked at in their report featured phishing in one way or another. Often it'll be combined with other attacks as well, but phishing played a part. That's how significant this form of attack really is. Now let me share just one more stat before we move on, and it's this one. Response average by motivator. This was put together by PhishMe, who provide a service for you to mount ethical phishing attacks in order to train your organization. Now, what's really curious here is the emotional motivators. And this goes back to the human weaknesses that we discussed earlier on in the course. So people are motivated to open phishing emails, open attachments, and even then follow links to websites which request personal information from them based on these human weaknesses. We've looked at things like fear and urgency and curiosity already. Reward is incentivization. I referred to it as greed. If you do this, you will get money. Connection, if you can be convinced by someone who you think you know to perform a particular action. So I really like the way PhishMe is representing emotional motivators because it ties back phishing to social engineering. And it just goes to show how the adept phisher is able to target the human weaknesses within all of us by well-crafted phishing attacks. Now, just before we start looking at some actual phishing emails, I want to touch very briefly on several real-world examples of where phishing has been successful. This is a great example of just how effective a phishing attack can be, and indeed how significant the real-world ramifications can be. Back in 2013, the Associated Press's Twitter account was compromised due to a phishing attack, and a fake tweet about an attack on the White House was posted. Now, this had a real-world ramification in that investors, thinking that this was a real terrorist attack, rapidly sold off stocks, causing the Dow Jones Industrial Average to fall more than 150 points. Now, it quickly recovered after that, but the point was that this phishing attack was successful and it did have a significant impact. 150 points on the Dow is a very significant amount of money. So that's one good example. Let's look at another one. In 2011, the security company RSA suffered a very serious attack. After the incident, the root cause was traced all the way back to a phishing attack, just like the one here in this Wired story. In fact, this was a phishing attack that was sent to the parent company, EMC, and the attackers targeted 4 co-workers there with an Excel document called 2011 Recruitment Plan. The document contained a malicious payload that exploited a 0-day vulnerability in Adobe Flash, and that then managed to drop another malicious file on that individual's computer, which gave the attackers a foothold into EMC's network. Now from there, the attackers eventually made their way into RSA and managed to steal information relating to the Secure ID two-factor authentication implementation. And it all began with an email just like this one and one person that opened the attachment. That's a pretty serious example, but there's one more I want to show you before I move on, and it's about a very familiar name. In 2013, the huge US retail store Target suffered a major data breach that resulted in the theft of 110 million credit cards. Now, this theft was due to malware running on the point-of-sale terminals. But the question was always this: how did it get there? Eventually, the attack was traced back to an HVAC provider. So HVAC is heating, ventilation, and air conditioning. And what we're talking about here is another organization that did business with Target. They managed some of Target's facilities. They were the victims of a phishing attack, and due to their access to Target's network, the attackers managed to pivot through environments and ultimately compromise the POS terminals. That turned out to be a very, very significant data breach, and it all began via a phishing attack, not even on Target themselves, but on a partner. So those 3 examples hopefully put into context just how serious phishing attacks can be. Let's move on and start to have a look at some phishing emails, and in particular the call signs that help us identify them as a social engineering attack. The thing about almost all phishing emails is that they do tend to adhere to some common patterns that the adept recipient should be able to identify before falling victim to it. I want to start to run through some of these patterns, and I'm going to use real-world phishing emails that I found in my email account. Let's start with this one. Branding inconsistency. We usually have a pretty good sense of what an organization's brand looks like. So in this case, the Canadian Imperial Bank of Commerce. If you're a customer of CIBC, you'd be aware of their logo, the colours they tend to use, the layouts they tend to use. If you were to see an email like this and ask yourself, is this consistent with the communication that I normally receive from CIBC, you'd have to conclude it wasn't. This is quite clearly a phish, and if you read past the content itself and look at the overall structure of the email, it becomes quite evident it is not in keeping with normal behaviour. And that's one of the key things, specifically about phishing, but also more generally about social engineering. Is this behaviour normal? Let's take a look at another example. Here's a PayPal phish, and for the most part this is actually pretty well put together. The branding is what I would expect from PayPal. It's got the PayPal logo, the PayPal colours. It's well formatted. But let's look at the sender. The sender's name has been entered as PayPal service. But look at the domain that the email address has come from. Update with 2 P's, -information.com. This does not look like a PayPal domain. So right off the bat, we should be suspicious just based on the sender. But we can also see an issue down towards the bottom, in that last sentence. Pay particular attention to the words please and your. The casing's wrong. They should both be lowercase. It should be a lowercase p and a lowercase y. And this is the sort of things that an organisation such as PayPal is very unlikely to get wrong. Now, we often see this in phishing emails. In fact, we often see much more obvious mistakes. We see spelling mistakes, we see grammatical mistakes. Mistakes that are unlikely to be made via a large organisation sending out emails like this en masse. Most phishing emails only take a cursory read through the content to figure out very quickly that they're not legitimate. But there are other patterns we can look for beyond just what's immediately visible as well. Have a look at this one. This is a really good example where here we have a hyperlink towards the bottom of the email, and the hyperlink is written as outlook.com. However, if we place the mouse over that particular hyperlink, we can see that it's actually going to go to a completely different domain name. So here the attacker is trying to obfuscate the underlying hyperlink, and they're trying to do this to trick us into believing that if we click that, we're going to go to outlook.com. Identifying suspicious URLs of what will ultimately be a phishing page asking for personal information is a really key skill when it comes to identifying a phishing email. Now, it's very easy to do this on a PC by just hovering over the link, but it's also very easy to do it on a mobile device by clicking and holding on the link. So here's what I saw on my iPad when I read the same mail. I don't have to follow the link. I just have to click and hold, and I can clearly see that this link is going to go somewhere entirely different to what it's representing. They're just a few very basic fundamental signs we can see in many phishing emails. But there are also other patterns to look for, in particular the patterns that exploit human weaknesses. Let me give you an example. Early on in the course, I spoke about various human behaviours that we would normally consider to be a virtue, actually being a weakness when it comes to social engineering. And sympathy is one of them, and this is a perfect example of how the attacker attempts to exploit that. So here, the email is represented as coming from someone who's suffering from ovarian cancer. This email is attempting to elicit sympathy from the recipient. It's one of the very first things that's said. But it then goes on and starts to exploit another human weakness. And I can show you that personified in this next email. Greed. As soon as people see an opportunity to make money, very often their better judgment departs them. In this case, the scammer is talking about $18 million, and all they need is a little bit of help from the recipient, and that person will retain 10% of the capital. It sounds very lucrative, but inevitably this will then descend into a phishing campaign where the attacker monetizes their efforts. As I mentioned earlier on in the course, when you receive emails like this, have a think about what is the weakness in you that the attacker is trying to exploit. Let's look at one more. Fear is another really common one. We spoke about that earlier on in the course as well. In this case, the social engineer is trying to convince the victim that there's a security problem with their Royal Bank of Canada account. All that the victim needs to do in order to verify their identity is just click on that link and then inevitably provide the attacker with what is usually quite an extensive amount of personal information. Consider a victim who is fearful of someone else accessing their bank account. Their guard would be down. They'd be very focused on how to protect their account and less likely to think about, is this actually an attempt to break into it? Now, of course, in a case like this, we can also see other call signs of a phishing attack. We can see that the email address of the sender is odd. We can also see that there's no formatting at all on the email. This is not what I would expect from a bank. So very often we're seeing multiple indicators of a phishing email when these attacks come through. Some people believe that such obvious flaws in the structure of the email is to try and separate the targets, such that only those that are gullible enough to believe this email will actually progress and then fill out personal information. So they'll be the high-value targets to the phisher because they've shown sufficient lack of judgment to proceed with the attack. Certainly, there could be a degree of that, but I'm also very fond of Hanlon's razor, which states, "Never attribute to malice that which is adequately explained by stupidity." So it may well be in many of these cases that those attempting to mount the phishing attack just simply aren't very good at it. So there's some call signs of phishing emails. Let's now move on and have a look at some call signs of phishing pages. As with phishing emails, you'll find that a phishing site, or a phishing page as it may be, tends to consistently exhibit a number of very clearly identifiable suspicious traits. Let me give you some examples, and I particularly want to focus on how to establish authenticity. Here's the first one. A page like this is requesting quite an excessive amount of information. Now in this case, the phisher is attempting to convince the victim that this is Chase Bank. And in order to verify your identity on Chase Bank, you need to provide all of the information you see here. Now common sense, and this is really the key because not all victims always exhibit a great deal of common sense, but common sense should dictate that if this is legitimately your bank emailing you, they already have this information. They may need some form of identity verification, but it is never this extensive under legitimate conditions. So immediately seeing requests for really extensive personal information should be an absolute red flag. Let's look at another red flag which is evident in this particular phishing site, but even more evident in the next one. Domain names. The legitimate website will almost certainly have a recognizable name. Now there are some exceptions to that which I'm also going to touch on shortly, but in a case like this, this is a PayPal phish, and it's a PayPal phish in German, yet we're seeing a domain name that doesn't look anything like what we would expect from PayPal. Not only that, but this attack, which is mounted in German, is on a French top-level domain. It's on a .fr, and that would be exceptionally unusual. So simply by doing nothing else beyond looking at that domain name, we can get a very, very quick sense that something here is not quite right. Now, irregular domain names are one thing to look out for, but the other one is IP addresses. You see a lot of phishing pages stood up simply on an IP address. A legitimate business will never do that. Certainly they never should do that. If you see it, do not enter any information. There's a very, very high probability of it being malicious. But there's another pattern that we can look for in the domain name as well. Let's go and take a look. Missing HTTPS. Any legitimate website requesting any form of sensitive information, such as an email address and password as you see here, will be served over HTTPS. There will be a padlock. You will be able to click the padlock and inspect the certificate and see that it was issued to the organization that you think you're visiting. It is extremely rare to see any phishing page served over a secure connection because they've got to have a valid certificate. And yes, they could stand up a fake domain and get a valid certificate for that fake domain, but then you should be able to identify that via the fact that the domain is not consistent with what you would expect to see. Plus, of course, if a phishing attack like that does happen, the certificate authority can always revoke the cert. So there's a recourse available there as well. So there are a few indicators that you can fairly easily pick up on phishing pages. But have a look at this one for a moment. Is this a phishing page? The branding looks good. The spelling, the grammar, the casing looks good. It's not requesting excessive information. It looks legitimate. We can have a look at the domain name up there towards the top of the screen, and it appears somewhat legitimate. Apple, iCloud, Mobi for a mobile device. Yet this is a phishing page. Let's look at this next to the legitimate page on which it's based. The only difference whatsoever that we can see here is the domain name. Now the main difference here is that we can see the padlock and Apple Inc. in green. So it's been served over HTTPS and Apple has an EV certificate, an extended validation certificate. so we can have a very high degree of confidence that we are actually looking at one of Apple's pages. But that is a very, very minor difference. This is a hard one to spot. And unless someone specifically knows what to look for, this one could very, very easily fool them. Not only that, but they even have a nice responsive design. Now, it's a little easier here to see that there's no padlock and there's no HTTPS. But again, it is a very, very good phishing page. Inevitably, in a case like this, the attacker simply takes Apple's legitimate page, copies it, and puts it on their own site. And then, of course, siphons up anything that's entered into the input boxes here themselves. So I wanted to finish with this one just to point out how effective well-designed phishing pages can actually be. You can still identify that it is indeed a phish, but it's exceptionally hard if you don't know exactly what to look for. So that's a bunch of call signs of phishing pages, and of course how to do one well. Let's now move on and take a look at spear phishing. Spear phishing is effectively a very targeted phishing campaign, either targeted towards an organization or to a specific user. Now, spear phishing campaign can be exceptionally effective because when they're targeted towards one specific entity, they very often repeat information about that entity, so that when the recipient receives the email, there's more information in there that gives them confidence that it is actually a legitimate email. Let me give you a perfect example of this. This is a spear phishing extortion email. I had someone forward this on to me after the Ashley Madison hack of 2015. And in fact, what happened in that case is that attackers were going through the breached database. There were about 31 million accounts compromised in the Ashley Madison attack, and simply emailing every single person in there and demanding that they pay Bitcoin in order to avoid having their presence in the adult website socialized. Now, what made this a phishing attack and made it especially effective is the personal information that you can see here in the email. Now, I've blanked it out, but you've got a pretty good sense of what goes in there. Things like the recipient's address and the last digits of their credit card and the payment that they last made. That is a very, very personalized attack. Now, of course, the phishers were able to do this because all of this data was in the actual data breach. So they could just simply enumerate through those 31 million accounts and automatically construct emails that had this information in them. Now, there never was any recourse for people that didn't pay. This was just simply a bulk email with the same Bitcoin address and the same demand sent to everyone. A few people would pay and the spear phishing attack would be monetized. The vast majority wouldn't, and the attackers just simply wouldn't worry about them. It's not worth their while to go through any sort of recourse. The attacker certainly isn't going to get any money if they do start, as they say, sharing the dirt with their friends, family members and spouse. But put yourself in the shoes of the recipient of this spear phishing attack. Seeing this very, very personal information there in the email, you would feel very compelled to respond to this. So that's spear phishing. Next up, I want to look at enumeration as a verification vector. One of the challenges for someone mounting a social engineering attack using a phishing campaign is actually finding legitimate emails to send the attack to. Particularly with spam filters being quite clever these days. If they send too many emails to people that immediately flag it as spam and don't fall for the attack, it reduces the overall effectiveness of the campaign. Other emails get sent directly to junk to other recipients as the campaign starts getting blacklisted. Now, one of the things that can improve the delivery of a phishing attack email is establishing that the recipient does indeed have an account on the service that the attacker is targeting. Let me give you an example of how that might be done. This is a website that I've created for many of my courses. It's publicly available. It's over at hackyourselffirst.troyhunt.com, and it has a whole bunch of security vulnerabilities in it. One particular vulnerability is a really good example of something that's quite beneficial to the social engineer wanting to mount a phishing attack. Let me show you what I mean. if I go over to log in and then forgot your password and I enter an invalid email address and then attempt to reset, I now see a message. The specified user does not exist. Let's try valid email. We'll try mine. And now attempt to reset. And now we see confirmation that that email address does indeed exist in this system. Now this is an enumeration risk, and I talk about this particular risk in many of my other courses. Courses such as Secure Account Management Fundamentals. And normally when I talk about this risk, I talk about a risk to privacy. This is just disclosed that I have an account. And it may be that I don't want other people to know that I have an account, because anybody could go to this password reset page, enter my email address, and then know whether I have a presence on the site or not. But for the social engineer involved in phishing, this performs another valuable purpose, and that is it confirms whether the individual exists on the site or not. If they were to get a response back saying that the person did not have an account here, then it probably wouldn't be worthwhile targeting them with an attack related to this particular site. Now put this in a valuable context like banking. If they could go to a bank and throw email addresses at the password reset form or the registration form, which often also discloses the presence of accounts, sometimes even the login form does it. But if they had a way of asking the website, does this account exist on your site or not, and the website told them, it allows them to create a much more accurate list of who they're going to target with their phishing campaign. So that's enumeration as a verification vector. And for all the same reasons as we don't want enumeration because of the impact on privacy, we also don't want enumeration to be able to act as a vector for someone mounting a phishing attack. Let's now move on and look at how the phisher attempts to evade filters and conceal their phishing payload when it is sent out to victims. A continual struggle for the phisher is actually getting phishing emails delivered through to the victim. Now, what makes this particularly hard is how well email clients and antivirus are evolving to recognize a phishing attack. So we just looked at common patterns of these attacks. And as much as we, as humans, are able to recognize these patterns, the machines are also able to establish patterns and then appropriately block or quarantine those emails in an attempt to protect their users. Now, of course, just like any other aspect of information security, this becomes an arms race, because now we have the phishers continually evolving to try and conceal the purpose of their emails. So just as defenses improve, so does concealment, and the whole arms race continues. Certainly though, there are a set of very common practices that the phisher does use to try and attempt to obfuscate the intent of the emails that they're delivering. Let me give you just a few examples. This looks like a pretty typical email, but what the attacker has attempted to do here is wrap everything up inside images. So we're not actually looking at text. It looks like text, but inside the body of the email, we've simply got images. Now what this means is that in order to properly defend against an attack like this, the email client or email service has to then OCR the images, so do optical character recognition, to figure out exactly what this email says. So it makes it that little bit harder. Now there's an easy way to tell that this email is all just images. Let me open up the original one and I'll show you. So here is the actual email. And again, this is one that was sent to me. Let me now move over to that email. I'm going to click somewhere in the body and then Control A to select. Now all I have here is blocks of images. It's not like up here in the subject where I can click and drag and actually select individual letters or words. If I try and do that in the body, it selects great big blocks one at a time. And this is very often used as a technique to try and evade the ability for a system to actually look inside the contents of the email and form a decision about whether it is legitimate or not. So that's image blocks. Let's have a look at another mechanism of filter evasion and concealment. Redirects are a really good example. Smart email services will look at where links are going to, and they have their own databases of what constitutes a malicious site. Very extensive databases too, mind you. So what the phisher wants to do is, rather than linking directly to their phishing page, which may already be blacklisted, is that they want to link to another page which then redirects to the phishing page, or in some cases has multiple different redirects along the way. Very often as well, these redirects will have other obfuscation techniques in them, so that if an email service, such as Outlook.com, received a phishing email and followed the link, they wouldn't actually be able to follow the link all the way through to the eventual target. Now, the best way to demonstrate this is I'm going to take one of the links in this email, paste it into Chrome, and we'll have a look at all the network requests that go with it, and we'll see how many times it actually redirects. So I'm in Chrome and I've opened up the developer tools. I'm also on the network tab, so let me paste in the URL from that phishing attack, and then we'll see what happens when we load it. Okay, so we can see that the phishing page itself is loaded in the background. I'm pretty sure I'm not today's lucky winner, and that I will be asked to complete many surveys and probably provide some personal information at the end of it. But we have also seen a number of requests. So let's jump over here and scroll up and see what's happened. Now note the first 3 requests. They've all resulted in an HTTP 302, a temporary redirect, and each one has responded to the browser and told it to go to a different location. So it redirects again, and then redirects once more before it actually loads at the target site. So in terms of tools that are actually looking to figure out where the links within potential phishing emails go, this can be a really effective mechanism. It really comes down to how intelligent the tool is and how well it's able to emulate the actual behavior of a browser. Let's look at another filter evasion and concealment technique. This is a very common practice. Have a look at the domain name. Now, when you start reading this, you read paypal.com, and many people will see that and then mentally pass the domain name test I talked about earlier on in this module. They see paypal.com, which is what you would expect to see on a PayPal website. But of course, this is just a subdomain. The actual domain itself is this service-secure with 2 E's in it. And paypal.com is simply a subdomain of that original domain. Now in this particular case, it also really helps that it's a well-designed phishing page. This is actually very consistent with the actual PayPal website. In fact, you can click through the other links and you remain within this phishing website. So it's quite well put together. So always pay attention to that. Don't just look at the start of the domain name and stop. You need to understand the entire thing. This is a great way of concealing the true intent of the site from the user. It won't trick automated defenses, which will just look at the full host name in its entirety, but it will trick us gullible humans who tend to just see what we want to see. Let's look at one more mechanism of concealment before we move on. This is another really common mechanism used on phishing pages. An attacker will compromise another legitimate website. In this case, it's the website at supreme9events.com. That's not a phishing website, that's a legitimate business. But in this case, the attacker has stood up their phishing pages well and truly down the directory tree. And you can see that just by looking at the path in the address bar. Now what this means is that firstly, any automated defenses are not going to work until this particular site gets blacklisted, or possibly the entire path, but certainly from the outset, it's an established, trusted site. And it also means that the attacker gets to sit on someone else's hosting, someone else's bandwidth, and ultimately, and very unfortunately, compromise someone else's reputation. Because inevitably what will happen is that the automated tools will recognize that this website is hosting a phishing page, and eventually this will get blocked. But again, it is enormously common. In fact, let's move on, and I'll show you how to find a huge number of phishing pages, just like this one here. I want to take a quick look at a service called Phishing. And the way I want to demo it is by starting with a phishing page just like you see here. Now I've got this URL on my clipboard, and I now want to jump over to the Phishing website. So this is Phishing. It's a free service run by OpenDNS, and it's a great way of searching for whether a suspected phishing page has previously been logged with the site or not. So I'm going to post the one that I just showed you on the previous slide. It's this one here. Let's do a search for that. And here we go, we have a result. This is just a static screenshot of the site. So if you were suspicious about a URL and you didn't actually want to click on it, you could come and plug it into Phishing and then get this static representation of what it looks like. The other really useful thing about this site is that if you're interested in seeing how these phishing attacks actually work, they have got a huge repository of them that you can browse through. Let's just jump home for a second. The ID of the latest submission currently stands at over 3.7 million sites that have been logged here. And what you'll see as you scroll down the page is a whole bunch of different URLs that have verified phishing attacks on them. Now you can scroll back through a huge number of them, millions of them, and go and review these for yourself. And certainly, if you're interested in social engineering and interested in how these phishing attacks are actually put together, go and have a look at some of these, because you can learn an enormous amount by actually seeing them in action. So that's verifying and finding more phishing attacks with Phishing. Let's now go and have a look at something quite different, and that's how to stand up your own phishing page with Beef. I want to demonstrate the effectiveness with which a phishing attack can be mounted using Beef, the Browser Exploitation Framework project. This is a fantastic project that makes it really easy to get very, very powerful control over target websites. And I thought the best thing to do here was to actually show you how it works. So firstly, Beef is available from beefproject.com. And ultimately, it's a website with an administration interface, and we're going to embed some JavaScript from this site into our target site on which we want to mount a phishing attack. So what I'm going to do first is jump over to that target site, show you how I've hooked Beef in, and then we'll see what we can do in terms of mounting a phishing attack. So here's the target site I've decided to use, and I referenced this just before in terms of account enumeration. This is the hackyourselffirst.troyhunt.com site, and it's got a flaw that makes it really, really easy to demonstrate Beef. Now you might notice that I have this site loaded in Firefox because I want to try and emulate a very independent browsing session from what I'm about to show you with the administration panel for Beef, which will open in Chrome. Now I want to show you how this works. I'm going to browse over to the leaderboard. And then from the leaderboard, I'm going to pick one of the vehicles here. Now in case you've not seen my other Pluralsight courses where I use this site, it's all about logging in, voting for vehicles that you like, and then leaving a comment if you so desire. Now one of the problems with this website is that you can leave a comment that's a persistent XSS attack. Let me show you how that works and how I'm using it for Beef. If I now go down and have a look at the SLS AMG Black, we'll see that the page loads and it looks perfectly normal. But I want to do a quick Control U and show you what's in the source code. And in fact, what I want to do is just scroll down a little bit until I find the persistent XSS comment that I left earlier. So here it is. It's line 116. And what you'll see here is that my comment is everything in this table cell. So effectively, it's the entire script tag. Now, what you'll notice is that this script tag is loading a file called hook.js off a totally different domain. And that particular domain is where Beef is running. So what's happened is that this browser session has loaded in this JavaScript file. Now let me close the HTML source and hit F12 for the developer tools, jump over to the network, and what you'll see is that this page is continually polling. So I'm showing you this in real time. And what you're seeing here is every few seconds, it's going off and making a request to hook.js. Now what we can do is instruct this website to behave in a very phishing-like way by using the administration panel as the attacker. So we're really looking at the victim view here in the browser. Let's close the developer tools and I'll Alt-Tab over to the administration console for Beef. So here's the admin, and we can see that I have one online browser here at my present IP address. There's an offline browser there where I was doing some testing earlier on as well. Now the first thing we can see here is extensive information about the hooked browser. So everything from the user agent to the platform, all the way down to things like the cookies. Effectively, everything that could be retrieved via client script. What I'm really interested in though, in the context of phishing, is some of the commands that we can issue over here. What we see now is a bunch of different modules that we can apply to that hooked browser. But being a social engineering course, I want to jump down to the social engineering category and apply one of these attacks. And the attack I want to use is petty theft. Now what we can do here is choose the dialog type. So which social media provider would we like to phish credentials from? There's some typical options in here. I'm going to go with Facebook though. Now as soon as I hit execute, I'm going to Alt-Tab back over into that Firefox session because I want to show you what happens next. Now remember, this Firefox session is continually polling the Beef website, and here is what has just happened. Beef has sent back instructions with a social login dialog. Now have a look at what we're seeing here. This looks like a legitimate Facebook login. Many people would see this appear on their screen and not think twice about entering their Facebook credentials. Let's enter some info and see what happens. I'll enter my legitimate email address and a fake password. Let's now log in. So, as far as we can tell, that's just logged us in. This would not be an unusual behavior, and someone who was not aware of the risks of phishing probably wouldn't think twice about this. However, let's now Alt-Tab back over into our attacker's browser in the Beef administration website and see what we now have. We can see in our module results history column here, we've got one command having been issued. Let's take a look at this one. And here over to the right, we can see the command results. The answer shows my email address that I just entered, and the password that I provided was password with a 0. So this has successfully phished the information out of the target website. Now I could have embedded that hook any one of many different ways. I used persistent XSS. I could have used reflected XSS. I could have also used SQL injection to embed it into the database. Or if I had access to the transport layer, I could have added it in using a man-in-the-middle attack. If there was a vulnerability that allowed me to write to the file system, I could have just added it to the underlying files within the web application. There are many different website vulnerabilities that could allow an attacker to modify the contents of the site. Let's try one other option. And in fact, just whilst recording this, I can see that in the online browsers, there's another one that's just appeared. So the Hack Yourself First website is a public site that many people watching my courses do go along to. So right now, I've actually got someone else hooked as well. But I'll leave them alone and instead try a Google phishing attack. Let's just run that with all the defaults. I'll Alt-Tab back over to the site, and now let's see what happens. And again, we're just waiting for that hook to fire. So for the browser to make a request back to Beef and get its next instruction. And here it is. We can now see what looks like a normal Google login page. Now, of course, the URL is not correct. And certainly we don't have a valid certificate or anything that would allow us to be confident that we are actually talking to Google, but let's fill it in anyway. I'll use the same credentials again. Let's now sign in. Now this has actually redirected us back to Google. So as far as the end user can see, it didn't actually log them in. But we are back here in Google. It does look legitimate. And indeed, this website is legitimate. It's a valid Google domain, and it's served over HTTPS with a valid certificate. But let's now go back to the Beef administration panel and see what we have. There's the command that was issued. We'll click on that. And again, here's the same result. Another phished username and another phished password. Now, Beef goes well beyond that. You can get a bit of a sense of just how extensive it is based on the module tree. But I hope this has given you a good idea of not only how powerful Beef can be, but just how easy it can be to mount a very, very convincing phishing attack.